Hello, and welcome to another episode of Boundless Body Radio. I'm your host, Casey Ruff, and today we're releasing a special episode from a project that I undertook in 2022 called the Boundless Body Radio Premium Podcast. My intention was to take all of the best clips about one particular topic from all of our episodes and put them together as a masterclass to be released behind a paywall and with a subscription-based service on Patreon. Well, we didn't have many subscribers, so I'm breaking these episodes up and releasing them here for free so they can make an impact and hopefully help some people out there. Today's episode was taken from the first series, all about the 3 macronutrients. This is part 1 from the first episode, all about protein. We actually did release this entire conversation back on episode 324 to tease out the Boundless Body Radio Premium Podcast, but we still wanted to re-release it here and just keep everything in the same order, essentially. We always appreciate any feedback that you might have, so feel free to leave us a comment on YouTube or on our website at myboundlessbody.com, where you can always book a complimentary 30-minute session with us at any time. Cheers and enjoy part 1 of this 2-part conversation all about protein. Hello, and welcome to this episode of the Boundless Body Radio Premium Podcast. I'm Casey Ruff, and I will be taking you through our content today, which we are going to focus our very first episode on, which is protein. Protein is such an important macronutrient, one of the main 3 groups of food of things that we can eat. And we wanted to start with some exclusive content. So this is not something that we have released on Boundless Body Radio. We interviewed Michelle Hearn, who is a registered dietitian, and she is also the author of the book, The Dietitian's Dilemma, which is fantastic. I highly recommend it. We interviewed her on episode 70, but again, this is premium content, exclusive content that didn't appear on that episode. We are going to learn directly from Michelle what protein is and why it's so important.
Yeah. So, when I think of protein, the first thing that always comes to my mind is it's from the Greek word proteus, which means of first importance. So, out of all the macronutrients, protein is by far one of the most important. When it comes to, we have 3 different macronutrients, right? We have carbohydrates, protein, and fat. We have essential amino acids, protein, meaning you will die without these. You have to get these from your diet. We have essential fatty acids. So there is fat that you actually have to get from your diet as well. There's no essential carby acid. We could talk about that on another time. But protein is incredibly important, right? So protein is basically, broken down into amino acids, and they have many different functions in your body. Most people associate protein, it's for muscle strength. And while, it certainly does, it is important in muscle synthesis, right? You need it to build and maintain muscle. But what protein also does is it's very impactful when it comes to hormone function. It has so many different things in your body. It's important for your cells to communicate. It's important. I just lost my train of thought. But it has a lot of different functions. Your skin, your nails, your hair. Protein is absolutely essential. And we also know that protein has roles in your brain function. Amino acids, the different amino acids can actually impact how your brain works or doesn't work. So when I think of protein too, I don't just think of, a lot of people used to say it doesn't matter where you get your protein from. You can get it from beans or you can get it from steak. And we know now that that is just not true. One of the experts on protein and protein synthesis is Dr. Gabrielle Lyon. And she worked in geriatric care for many years. And I believe she probably still does. And what she saw, and what I also witnessed in the hospital setting, is a lot of our elderly population. And when I say elderly, I'm not even talking 90, 100. I'm talking 50, 60. I'm almost 40. We even saw it in people as young as their 30s are having muscle wasting. We have a population who's overly fat and under muscled. And muscle is such an incredibly important thing to have as you, especially as you age, even for just the simple task of being able to do activities of daily life. Can you lift your groceries? Can you pick up your dog? Can you empty the dishwasher? Can you shower? All these things that if you're a healthy person, you may take for granted are very important to have muscle.
Yeah, no, that's so critical. I had to laugh to myself because in the very beginning, like you're talking for 5 seconds and I'm already learning something new about protein that I didn't know. Like this is how we know we find our people. Michelle Hurd is just so amazing, educating us right from the get-go. I absolutely love that. You brought up protein sources, which I think is a really important thing to kind of talk about. I learned from the great plant-based con by Jane Buxton that yes, you can kind of do all these like crazy mental gymnastics to combine different plant foods to then get to a certain amino acid profile to give you a complete protein. But that means you're eating several cups of lentils and mixing that with several cups of spinach. You're also getting tons of carbohydrate and anti-nutrients and all these things that come with it. And it's like, you can maybe kind of sort of combine all these plant foods to get the protein you need, but it's going to be very difficult. And you're going to get a lot of other crap that you maybe don't want with that. So tell us a little about protein sources and the difference between animal-based and plant-based protein.
Yeah, I was recently at the ketogenic conference in Austin, Texas, and one of my favorites, back to Dr. Lyon, was talking. She had a graph that showed this very well. Talking about if you want muscle protein synthesis to happen, if you want to make sure your muscles are recovering, maintaining, building, you have to get enough leucine. Leucine is an incredibly important amino acid, and she was showing like, can you do this with plants? Yes, like you said, you can. But are you going to eat 12 cups of quinoa every day? Are you going to eat 40 potatoes? Are you going to eat, like you said, this much beans, spinach, tofu? And when you eat those things, like let's say you did, okay, you would be consuming a very high amount of calories, 3,000-4,000 calories just to get that amount of protein. And so if you're not exercising, 6 hours a day, which we know statistically most Americans get 0 minutes of exercise, then that's a big problem. Also, anytime you're eating a lot of plant products, we know that things like seeds, grains are very high in phytic acid. Phytic acid is very similar to fiber, and then it binds to calcium and iron. So, iron deficiency is the number one mineral deficiency worldwide. It's estimated actually that 50% of our children under the age of 5 are deficient in iron. And it's like, well, what are they eating? Are they eating, animal products, liver and beef? No, they're eating lots of these rices and seeds and peanut butters and toasts and things. So the amount of, beef or even like whey protein isolate, I'm certainly always an advocate for real food first. But the amount of calories that you would need, it's astronomical. It's like you could get 300 to 400 calories of beef, or you had to get 2,000 calories of potatoes. And obviously, like you said, that would come with so many, hormonal impacts on your blood glucose and insulin and potentially cortisol. So when people say like, oh yeah, you can get it from plants, the truth is you really can't. Most human beings are not going to do that, are not going to be eating that much plants. And if you do, you're going to suffer a lot of other negative health consequences. So, when it comes to what type of protein can my body actually use? I always say every species has a species specific diet. I have a dog and I have a tortoise. They are both fed very differently. My tortoise eats kale and romaine and grass. My dog eats liver and salmon and things that carnivores eat. And when you don't feed your species specific diet, they can get very sick. Yeah. Humans evolved eating, animal protein, meat and fat. And did we eat, roots and tubers and things like absolutely. When those were available or there was like a famine or whatever, absolutely. We know throughout history, especially if you live closer to the equator, you probably had more access to vegetation. But it was always, animal products were always prioritized just because they were so dense in nutrition. And like something like a steak, people like, oh, protein. It's not just protein. This would be my main point, it is what is in that is going to positively impact my body, that is going to fuel my body. It's the B vitamins, it's the carnitine, it's the taurines, all the different, even the cofactors, that are in this product, that when I eat it, my body uses it. It works perfectly and synergistically to not only build muscle, but to ensure that I'm a healthy, functioning human. When we eat, things like, these fake burgers and tofu and soy, our bodies are not really meant to utilize and digest those things, and that's why a lot of people will have gastric distress and problems. We know the vegans and vegetarians, this is not debatable. This is just statistically have higher risk of stress fractures, have lower EPA, DHA, and often are deficient in protein. So yeah, when animal protein, just simply said, your body can use and absorb it. If your body can't use and absorb it, it doesn't matter how much nutrition is in something.
That's right. That's right. And that's why those nutritional labels can be so deceiving. You think you're eating that can of spinach and it says you've got so much protein on the back, you're going to turn into Popeye. And that just doesn't work because you're right. It's not just what you consume, it's what you absorb and take into the body.
Exactly. And that's a very simple way of putting it. Like, it does not matter. I always use the example of, like, if I wrote you a check, like, hey, Casey, here's a check for $1,000. And you're like, awesome. And you go to cash it. And they're like, oh, she only has $17 in your bank account. You'd be like, oh, that sucks. It doesn't matter how much I write the check for. It matters, can you access the funds? Just like it doesn't matter if spinach has, 2 or 3 grams of protein in it. If your body cannot actually access and use it, it is effectively useless to you. And if you are eating a lot of quinoa, eating a lot of soy, thinking, man, I'm getting all this protein, your body can't use it. And it comes with a lot of those anti-nutrients. It comes with a lot of that fiber and this phytic acid and things like that. So you're actually doing yourself a huge disservice if you're prioritizing plant protein versus animal protein.
Yeah, that's such a great point. I love that analogy as well. We really appreciated that exclusive content from Michelle Hearn, who is a registered dietitian, like we said. And we're going to be coming back to her at the end. She's going to give us a little bit of insight before we close the show, which is great. We are now going to go over to Dr. Ted Naiman, who has written extensively about protein, especially in his book, The PE Diet, which is a fantastic way to understand how protein is different than the energy sources that we get in our diet. We couldn't think of a better way to get this thing started by asking him about protein. So we're going to go back to the original episode we did with him, which is episode 45. I highly recommend that you go back and listen to that episode in its entirety. You can also follow that up with episode 281 that we did with him as well. But we are going to tune in and listen to his explanation of protein and how it fits with some of the other macronutrients. Let's talk about the concept behind your book, because I think it's so well done and well said, and it makes it really easy to understand. It makes it easy for other people to understand. So let's talk about that concept, the PE concept.
Got it. Okay. Well, thank you very much. And so basically what I did is I zoomed way out to look at what the heck eating even actually is, right? So humans are animals, and animals are only alive because they constantly ingest other living organisms. So we just eat other living things for energy and protein and minerals and all the stuff that we need to build our bodies. But what's really at the base of all food for all animals is plants. So plants create all food for all animals. They create food for themselves. They're what we're called autotrophs. So plants make all their own food. They make all the food for animals. And they're specifically doing 2 things. They are collecting solar energy and converting it into chemical energy, just in the form of high energy carbon, and carbon hydrogen bonds, and carbohydrates and fats. So carbs and fats are just 3 elements, carbon, hydrogen, and oxygen, chained together with these high energy bonds. And then humans store these carbs and fats and break apart these bonds in our mitochondria. And that's how we get every single bit of energy to power every single thing we do to be alive. So we've got dietary energy, which is just solar energy stored as carbs and fats in these bonds between carbon, hydrogen, and oxygen. And then we have a very specifically separate thing that plants do, and that is sucking up minerals out of soil and primarily nitrogen to make protein. Protein is different from non-protein energy. Protein has nitrogen in it and other minerals. There are other dozen or so minerals that are essential to life, and plants provide all of this by sucking it up out of the soil. So you can kind of look at all of your food and divide it into 2 categories. There's protein and minerals, which come from soil and is predominantly nitrogen. And then there's non-protein energy, which is all just carbon, hydrogen, and oxygen chained together as carbs and fats. And so by zooming way out and looking at your diet in terms of protein versus energy, you can already sort of see how there's a little bit of a divide there. And then what ends up happening is that over the past, 10,000 years since we invented agriculture, humans have just figured out how to provide more and more energy in our diet, right? It was when we were hunter gatherers, it was pretty easy to get protein. You went out and just killed an animal and ate the whole thing, and you got a bunch of protein. But this animal might have already been starving for energy itself, and you're starving for energy, and you're trying to add more energy to your diet any way you can. And so we invented agriculture as a way of increasing the energy in our diet. We figured out, hey, if we grow all these starchy carb crops, all of your grains, we have this ready supply of carbohydrate energy that we can dump into our diet. Or if we protect animals and keep them in a safe place their whole lives and feed them really well, they get fatter and fatter. We can add energy to our diet in the form of animal fat, right? So we domesticated animals, made them fatter, invented dairy and consuming milk. We grew all these grain crops. We just figured out how to add more and more energy to the human food supply. And then with the Industrial Revolution, we figured out, oh, hey, you can just suck all the carbs right out of something and just have a giant pile of sugar or flour. It's just 100% pure dietary energy, non-protein energy, right? You can also just suck all the oil out of plant foods like industrial seed oils, or just suck all the fat out of an animal, with like bacon and lard and heavy cream. And we figured out, we can refine these carbs, refine these fats, dump them in the human food supply. They got cheaper and cheaper and more ubiquitous and an infinite shelf life. And what you end up with is humans went from about 33% protein, 33% of calories from protein when we were hunter-gatherers down to about 12.5% of our calories are protein now in the standard American diet. And all of these refined carbs and fats got dumped into the human food supply and created our global epidemics of diabetes and metabolic syndrome. And they do this specifically two ways. Number one, all of these refined carbs and refined fats dilute out protein and minerals in the food supply. So you literally have to eat more calories just to get enough protein and minerals to not be hungry. So the satiety per calorie is way, way lower now. The other thing that happens is high energy density carbs and fats together is something you don't really ever find in nature. And it massively drives overeating in omnivore mammals because it's so rewarding on a brain level. You get such a dopamine spike from pizza and donuts and candy bars and anything that's high energy density carbs and fats together. So basically, refined carbs, refined fats, it's all pure non-dietary non-protein energy, and it got dumped in the food supply, and now everybody has to overeat calories to not be hungry, and satiety per calorie is really low. And so the whole point of this PE diet is to zoom way out and look at your diet from this protein versus non-protein energy standpoint, and then try to target the protein side a little harder so you get higher satiety per calorie and you automatically eat less. It turns out that there's this protein leverage phenomenon where the higher the protein percentage, the food that most mammals eat, the less they're going to naturally eat. You just automatically eat less when the protein percent is higher because you have higher satiety per calorie. And so that's kind of the big picture, right? It's like zoom way out, think about what eating even is, divide it into protein versus non-protein energy, realize that all of our problems come from dumping in all these refined carbs and refined fats and just pure energies into the food supply, and then go out of your way to try to kind of reverse that trend, if you know what I mean.
So is this maybe the reason why I crack open a bag of potato chips and never on my fourth bite have I said like, whew, that was great. That was great. I'm stuffed. I can go do anything now. I've got great energy. I'm totally full and satiated.
Yeah, exactly. I mean, exactly. It's like, okay, your 10-ounce bag of potato chips, it weighs almost nothing, and it's just basically dehydrated carbs, refined fat. You eat that thing, it's 1,600 calories, and you're hungry in like 3 hours. You might even be a little bit hungrier than before you even had the potato chips. Versus you'd have to eat, 20 eggs to get the same number of calories.
Wow.
And if you eat 20 eggs, you're not hungry probably for the rest of your life. Like you're literally never going to be hungry. You might not even physically be able to do it.
Yeah,
and that's kind of how this works. It's like satiety per calorie is everything. And the hard-boiled egg has this crazy high satiety per calorie. And your potato chips have horrifically low satiety per calorie. In fact, it's one because it's you really improve satiety per calorie with protein, fiber, and water. And since potato chips have no protein, no fiber, and no water, and they're dehydrated, it's actually the number one food most associated with human obesity is the potato chip. And the reason is because it's totally devoid of protein, fiber, and water, all the things that would improve satiety per calorie. So these dehydrated carbs and fats together are the absolute worst for fat gain.
Absolutely. You made me think of the scene from Cool Hand Luke. Remember that? No man can eat 50 eggs, and he tries to eat 50 eggs in an hour and just barely gets the last one down. Great movie. I got to watch that tonight. When I was back at the gym, we would sit down with people and kind of explain nutrition. And we had a little handout that I would use that I found to be really helpful. And it was basically all the different components of a meal that you could mix together to have a healthy meal and thus a healthy diet. And so this would be basically all the macronutrients. And there were 4 different categories. There was protein, there was fruits and vegetables, there was carbohydrates that said like starchy carbohydrates, and then there was fat and it said healthy fat. So what we would do is tell people, like, if you put all these things together and do this like 80% of the time, probably you're going to be pretty healthy and happy. If you want specific results, now you can make some adjustments, pull some levers, change some of these things to get specific results. If you want to lose weight, maybe you could do this. If you want to gain muscle, maybe you could do this. And you could change those things and manipulate them to get a desired outcome. And it was really helpful to explain what things do, but also what things maybe don't do, because I see people expecting something, but they're eating something that could never give them the effect that they want. And this paper would start out with protein. So I'd love to just kind of talk about protein. Why is protein important? It's the biggest, most important thing in your book. You mentioned the satiety. You mentioned what we use protein for, but what sources of protein are your favorite? Why do we need them in the diet?
Gotcha. Okay. Well, protein, first of all, protein's the thing that you have the biggest need for every day in terms of a macronutrient. So most of us have enough energy calories in our body to live for a couple months without eating any energy at all. But protein, you have this very real turnover daily. And if you're not eating protein, you're going to break down your lean mass, which you really, really, really don't want to do. So protein is your biggest need on a daily basis. It's also the most satiating macronutrient by a very wide margin. So if you're going to eat anything, make it protein. You have to eat protein. And you can literally just scale up protein percentage and make pretty much any omnivore mammal thinner and thinner and thinner. If you get protein to 50% of calories, you're just going to get, in an animal model, you're going to get an animal whose phenotype has the very highest lean mass and the very lowest fat mass. And the exact same thing happens to bodybuilders. Most of your elite bodybuilders are getting their protein percent of calories up to 40, probably 50%, maybe even temporarily slightly higher than that. And you just automatically get the highest lean mass at the lowest fat mass. So this protein and protein percentage is probably the biggest deal of all, in my opinion. And it seems to be the biggest lever you can pull when it comes to improving body composition. Because what everybody really, really wants, whether they know it or not, in terms of body composition, is the highest lean mass they can achieve at the lowest fat mass.
Agreed.
And that is accomplished by increasing the protein percentage of your calories, quite honestly. It's just as simple as that. Everything else really fades into the background. So protein is definitely primary. And the higher the percentage, the better your body composition outcomes are going to be within reason. You cannot eat 100% protein, but it's definitely on a sort of a scale. You know what I mean? It's kind of on a spectrum. In terms of my favorite proteins, Well, we know from protein digestibility studies that animal protein is superior to plant protein. It's more complete. You can really talk to any vegan bodybuilder who's using plant protein supplements, and they'll tell you that you have to eat more plant protein to get the same anabolism that you would from animal protein. So, like egg and dairy proteins have very, very high digestibility and availability scores. And a plant protein, you might literally have to eat 1.5x as much grams of a plant protein to equal the aminos in animal protein. So it is definitely inferior. You can accomplish this with plant protein. You just have to eat even more of it. And it's even more difficult because the protein percentage of plant foods is inherently lower to start with. And the reason this happens is bioaccumulation, right? So like grass is growing and it has roots and it can suck some nitrogen out of the soil, but it's very limited by its root system. So it can only get so much nitrogen in its tissues, and the nitrogen is going to be fairly low. Now a cow comes along and just walks all over the place and eats 100,000 blades of grass, and it bioaccumulates all this nitrogen and concentrates it. So the amount of nitrogen and protein and minerals in the cow is going to be much, much higher than the grass, just due to bioaccumulation and biomagnification, kind of the way you get more mercury in bigger predatory ocean fish as you go up the food chain.
Great
what
point.
I mean? You bioaccumulate mercury just like you would something that you actually wanted, like nitrogen. So, yeah, my favorite proteins, honestly, are animal, and there are animals that were eating what they were supposed to be eating. So, like grass-fed ruminants are awesome. Pastured eggs are awesome. Wild-caught seafood is awesome. Dairy, that's where the protein's magnified by either being low carb, low fat, fermented, or all the above, is really awesome as well. So my favorite proteins are basically grass-fed ruminants, wild-caught seafood, pastured eggs, and some sort of fermented low-carb and low-fat dairy.
That's awesome. Very well explained. We're talking about protein first, but you recommend literally eating protein first. Is that correct?
That is absolutely correct. Right. So if you're hungry right now, you don't really know exactly what you're hungry for. Now, humans have an appetite for, basically 4 specific things: protein, carbohydrate, fat, and then minerals, most notably sodium and calcium. So if you're hungry right now, you don't really know what you're hungry for. Hunger is a very nonspecific signal. It's like, okay, you need to ingest more of something for some reason. You don't know what, you don't know why, you're just hungry, right? So if you go way out of your way to target the hell out of protein and minerals, and you eat something first that's tons of protein and tons of minerals, and you eat all of this and you hit your nutrient target for these protein minerals, then what you're left with, any hunger you're left with, is more of an energy hunger, and you might want to eat some additional carbohydrate, fat, or ideally a little bit of both. But you're in a much better place to know how much non-protein energy to eat. So I literally recommend eating protein first. That's exactly what we're recommending in the PE diet. Is you target this protein first, you front load all of this protein, and then you're in a much better place to know if you even really need to eat any energy. If you're really over fat, you might not need to eat a lot of energy.
So as we continue with this interview, I just wanted to point out at this point of the interview, I do ask Dr. Ted Naiman if he has any specific recommendations for how much protein somebody should be consuming in a single day. And I just think this is hilarious. It didn't occur to me at the time, but when you hear me agree with him and say like, wow, no, that's exactly what I do and how I recommend protein intake for my people. I did not realize at the time of this interview that I had already stolen this advice from Dr. Ted Naiman a long, long time ago. So I just think it's kind of funny to point out. You can see how like, wow, like I'm really like sure of myself here. It's pretty funny. So protein is super important. It's essential to the diet. It helps us with our lean mass. I'm glad you said lean mass and not just muscle mass, because that's what everybody thinks of. But there's a lot more to lean mass than just muscle. Focus on animal proteins. The higher quality, the better. That's all really good. We're on board. What is your recommendation for amount?
So for me, bare minimum protein goal for everybody is a gram per pound of ideal body weight. So not what you weigh, not what your lean mass is, not any sort of complicated formulas or anything. It's just like, what is the reference weight for your height and gender? Like, what should you weigh? And then I would eat a gram per pound. So like, I'm 5'10", and reference ideal body weight for a 5'10" male is 160 pounds. So like for me, a bare minimum would be 160 grams of protein per day. Even if I'm underweight and I only weigh 130, I would still have 160 as a target. Even if I'm hugely overweight and I'm 400 pounds, I would still have this 160 as a baseline target for everyone. That's what I'm recommending in the book. A gram per pound of ideal body weight.
Perfect. That's exactly the same recommendation that I use for my people. That's perfect. And you kind of have to clarify for some people, like, it's just really to say, like, if you're 400 pounds, no, you don't necessarily need to eat 400 grams of protein, but you should be somewhere in that ballpark of 1 gram a pound of protein per ideal body weight. So perfect. I love that. Next, we are going to be learning from Professor Stu Phillips, who is a world-renowned protein researcher. He is an absolute expert in muscle turnover. We have been honored to host him 2 times on our show as well, back in episode 71, and also more recently in episode 282. And that's where we're going to go for this clip. The clip is about 20 minutes long, and we are going to be discussing a little bit about the things that he has learned about animal versus plant proteins over the years. We're also going to talk about longevity and the appropriate amount of protein that people should be eating. Where are you at currently with thinking about the importance of intaking protein?
Yeah, so I mean, I think it's definitely still above the recommended dietary allowance, and I've often said to people that I would actually be happy if we just changed the name of the recommended dietary allowance to the minimum dietary intake. In other words, it's not what's recommended, and it's, you're allowed to eat more. And so if you just say that's the minimum dietary intake, I think at least twice that much. And so you go from 0.8 grams of protein per kilo up to 1.6. So it's probably about 0.6 to 0.7 grams of protein per pound of body weight, unless you're fairly overweight. And I heard a brilliant algorithm from a guy named Eric Helms the other day that says if you took your height in centimeters, which is another one, okay, we got to do the conversion, but let's say it's that number of grams if somebody's overweight. And it turns out to be a ridiculously good predictor of probably where they should aim. But let's just say it's more than is recommended. It's not as high as some people would recommend. It's it's close to the 1 gram per pound, which is the bodybuilding sort of axiom. But I don't think that most people are training hard enough to really put themselves into that sort of spot. I do agree that if you sort of quote unquote overeat anything, overeating protein there's less of a downside than there is for carbohydrates and fats. You flip that all over and you've got people, protein causes kidney disease, and that's definitely not true. It's off the table. It's an old hypothesis. It just needs to die. Protein causes your bones to be soft, and that's also untrue, particularly if you're getting adequate amounts of vitamin D and calcium. And the latest one is protein drives cancer. And that's a tougher one to sort of push back against. But again, when you look at the observational data from humans, so associations between protein intake and cancer, it's decidedly mixed. So there's some no effect. There's others, low protein is actually a bad thing and people die earlier. So, when you have sort of things that go either side of the equation, you have to ask yourself whether it's a true, what we call, a true signal. So I'm going to stick until proven otherwise to the twice as much as people are telling you need, and debunk the idea that everybody's getting enough, particularly as people get older. Because that group, when you're beginning now to lose muscle mass, I think is a group that could definitely stand to eat more protein.
Interesting. Yeah, I totally agree. I'm probably stealing this from the same podcast episode I was just mentioning with Peter Attia and Lane Norton. But I want to say, like, if it were true that, you know, a very high protein intake would cause cancer, wouldn't we like kind of sort of see a lot of people who are active and in the gym, who are actively working to gain muscle? Wouldn't there be an explosion of cancer at some point with them that we may not say this is causative, but like there's some correlation here?
Yeah. To your point, I mean, I think, you know, cancer's it's a tough one, right? Everybody says cancer and they put the umbrella over the top of it as if it's one disease. Whereas, you know, uncontrolled cell growth is definitely common to all of the types of cancer, but it's very different in one tissue versus the other. So I don't see an overproliferation of certain types of cancers in people who are in the gym. So maybe, again, borrowing a line from a good friend of mine, Mike Joyner, that I really enjoy, which is that exercise is the forgiver of many sins, is that is what is allowing you to do something, and the protein is actually supportive as opposed to being a negative or a down regulation or an up regulation, whatever it is in people who are not physically active. So I think, you know, again, it comes back. A lot of the reasons I eat is because I enjoy having a beer every now and again and a glass of wine, and I like cake, you know. So people say, "Oh, you're eating that cake," and I'm like, "Yeah, I mean probably another 30 minutes on the bike tomorrow, but big deal, you know." So, not to be too cavalier. I mean, I think the point is definitely you can probably dodge a lot of poor lifestyle or poorer lifestyle choices as so long as you're physically active.
Yeah, gotcha. As far as longevity goes, I want to say this is rodent studies, and maybe this is what you were referring to earlier. When we're talking about longevity and restricting protein, that if I understand it right, it has been shown to increase longevity, but again, it's only in rodents. Is that correct?
Yeah. I mean, so the calorie restriction or the energy restriction is the bigger of the two fields. In other words, that's sort of, it's pretty conclusive that if you do that and everything up to primates, we've got two actually studies that conflict a little bit with a certain species of monkeys. So I'm not sure whether that's convincing, but I mean, you know, being lean and keeping a low body weight is sort of, you know, intrinsically, you know, that's a good thing. And so you look at these primates that are calorically restricted and they look much better than the primates that are sort of, well, I'll call it ad libitum fed or overfed or whatever you want to say. So I guess the question is caloric restriction when something is in a cage and not exposed to the environment, not exposed to pathogens like a virus, you know, are they in better shape? And you can get the same effects when you restrict protein. And it's probably, the mechanisms appear to be slightly different, but I'm sure that there's some commonality around not promoting growth of tissues that shouldn't be growing. And that's the cancer story. So, you know, from that perspective, I hedge my bets a little bit on the protein restriction story, which, as you say, is predominantly a rodent story at this point. And go then to, we don't have a randomized control trial, so we have to use observational data and say, you know, there's observations on both sides showing protein restriction is good or less protein is good. And then, you know, more protein is good. So that's when you sort of go, well, once you have evidence on both sides, to me, then it's a lot of noise and you can't really find the true signal. And so I stop short of saying what works for rodents is therefore good for people.
Yeah.
And, you know.
Yeah, that's a really good point. One of the places where we seem to get more and more noise, I think, is the difference between plant protein and animal protein. And it was looking so strong for so long, like animal's the best, plant protein will not work, cannot work. And now it seems like there's more research and study coming out that's saying, yeah, there's a few caveats, but plant protein can actually work for a lot of people.
Yeah. Like, I'll be honest and, you know, put my hand on my heart and say I'd be a crappy scientist if I ever said that, you know, I'm not changing my mind on that, despite evidence that we've even generated in our lab. And probably are as guilty as some people as others of saying that animal protein is superior. We've known that for a long time. The superiority comes from a better profile of essential amino acids, a higher digestibility, and maybe the ease of availability. Like it was just easy to get and hit your protein targets with animal protein. 10, 15, 20 years ago when I first started at McMaster, I said, yeah, hands down, animal protein, dairy protein in particular, plant-based proteins, because it was pretty much soy. 20 plus years later, you look around now and there's pea protein, there's rice protein, there's cricket protein, there's, it's just enormous, the explosion of different sources of protein. And people have done work now where they've, treated proteins, they've sprouted them, they've cooked them, things that we probably discounted before. They're an important part of the processing before they actually go into your mouth. And when we do the studies and we compare them head to head, I find the differences. We thought they used to be, this big, and now we're finding if they're even there, they're pretty much trivial particularly for active people. So I think the other thing that's changed is, there's a much greater availability of plant-based products. And so it's easier, if that's the right word, to hit those protein targets that we once thought were just not achievable with, vegan, but maybe even vegetarian diets. But vegan, definitely, I'd be like, you're going to struggle. But now I think the gloves are off. And I think that the plant-based narrative has something to tell with respect to, preservation and even gaining of muscle. So I've got to dial back some of what I said before and go with that.
I was just thinking the two things that keep me humble in life is playing hockey with my buds when they just tear me to shreds every week, and being in the nutrition world. It's so incredible how many times we're just like, I don't know, changing our mind, saying like, yesterday it was so true, it was this, and now today I'm confused again. It's a constant.
Yeah, and it's frustrating, right? People want science to give answers, and they give the best answer based on the state of knowledge, and knowledge grows all the time, and everything where we've put plant-based, like pretty high quality plant-based or plant-based blends head to head against animal proteins, particularly milk-based proteins. There's very little difference. The only area where we're still a little bit underinformed is in older folks. And so we need to do some well-controlled studies in people who, are in need of more protein, and whether vegan, vegetarian type diets are still enough for them. But, hopefully that research will come around soon.
Yeah, it's good news for people that choose any different way of eating, that they can still get good results, whether they choose what I do or not. That's totally fine. Tons of different options. I'm not willing to trade in my steak for crickets at this point, but good to know that might be an option.
Yeah. No, I hear you. I like a good steak every now and again, but I have tried cricket protein. I was prepared for the worst, but was actually pleasantly surprised. So
Nice.
If you can get around the fact that it's crickets, there's, and I've tried a lot of foods, a lot of different places in the world, and it's sort of not quite fear factor, but I've said, you know what, these people are eating it. It's just a perception to overcome it. So so I've been impressed with the cricket protein, at least that I've tried, for sure.
Yeah, interesting. That's great. You did mention amino acids. For somebody that's not familiar with amino acids, can you explain, what they are and why, they're part of protein, obviously. But also there seems to be one in particular that just keeps coming up as like the most important one to talk about. Can you enlighten us about that?
Yeah, I mean, amino acids are the building blocks of protein. Unlike carbohydrates or fats, which are just fuel for your body, amino acids are the backbones of the protein structures that are our skin, our bones, our muscle, definitely, but our brains, our heart, our lungs, everything. And the one that, particularly for muscle, that keeps turning up, and it's again and again. And so this is, a big thing in the sort of plant versus animal protein world, is the amino acid leucine. And it's kind of like, once that amino acid arrives, it turns on the process of muscle protein synthesis, or making new muscle protein. And the other amino acids then are just the substrates for making new protein. So it's come down to the point now where I think if we can match leucine doses between two different proteins, then actually the rest of the amino acids are, I won't say immaterial, but they're a little bit less important. So if you can get plant-based, or if you can get even a very low quality protein and just touch up the leucine content by adding leucine if you want, then things tend to go a little bit better for muscle for sure.
Gotcha. I'm glad you brought that up. It seems like there's different amounts of protein to get to that critical level of leucine.
Yeah.
And correct my work. I'm not sure if I'm right on this, but I want to say I was taught that like with whey protein, a shake, you'd be like 27 grams. Most animal protein dosages would be about 30 to 40 grams. And so I would assume plant protein, you would need, 40, 50, 60 plus.
Yeah. You tend to get up into those types of numbers. The ones that you've sort of given as examples are pretty much spot on. The difference is now is that there are some plant-based proteins, and I know like I say corn protein, and people goes, how much protein is in corn? And I'm like, well, not much, but we grow a lot of corn. and we don't eat it all. I mean, that's so. A lot of it gets distilled into ethanol and everything else like that, and some is animal feed and everything else. But we can process corn to isolate what little protein it has. And for, people, I don't know why, but it's very high in leucine. So you can blend corn protein with other proteins and get up to that leucine dose at manageable amounts of protein. So, if you had 30 grams versus say 30 grams, I think the response would be just about identical. So, there are some plant source proteins that are higher in leucine, and everybody wants to know why. And I'm like, I have no idea. Like I don't know. I'm not a botanist, right? So, but that's just the way it's turned out. So it's blending some of these proteins that's particularly important. I mean, I think most sort of people understand beans and rice together that's the vegan blend that, you go everywhere in the world, and they figured that out. So, but yeah, some proteins, corn protein, which is, a South American staple in any type of sort of bread that they make, it's a pretty high quality protein. Eat that with some beans or some meat, and you're in good shape.
Wow, so interesting. So when we're thinking about the meals that we eat, or every like event where we're eating something, if all things were equal as far as the protein amount intake in a day, but somebody was eating a smaller amount more frequently versus somebody that was having a bigger bolus less frequently, would it be fair to say that the person getting the bigger boluses less frequently would be triggering muscle protein synthesis through taking enough leucine? Is that fair?
Yeah, I think, again, this is another one where I've got to rewind a little bit some of the stuff I said earlier in my career, and say that variable of small meals versus larger meals or whatever. I do think there is a sort of an optimal dose, and it's probably in that 20 to sort of 30 gram range. But for most people, that's a small variable compared to just getting the adequate amount of protein that you need within a given day. So let's say that, if it's 4 meals versus 2, or some intermittent fasters, it's just 1. And I would always say, that's not a very good way to do things. But then I see some people intermittent fasting and they're lifting at the same time, and they have some pretty impressive physiques, not to the extent maybe that they couldn't have them a little bit better with more protein, but it doesn't appear to be limiting any sort of gain in muscle that they make. So, from a purely sort of observational standpoint, I think that it matters more to hit your daily protein intake than it does, dividing it up over more meals. But, the stand pat is to say 4 eating occasions per day, try and distribute your protein evenly. But the evidence on that is thinner than it once was. Let's just say that.
Yeah, so interesting. So again, when we're talking about things like exercise, we're saying, generally speaking, you should exercise. You should lift some weights. Yep. Don't worry so much about all of these other variables. Almost sounds like the same thing in protein intake. Like we can maybe talk about how we're going to parse out all these meals and how much protein you're going to intake. But for somebody who's 80 years old and they're eating 50 grams of protein a day, just get more. Start with that. Just get way more than you're getting, however you get it.
Exactly. Yeah, I know. It's somewhat discouraging, and yet I enjoyed it at the same time to say that some of the prescriptions that we cared about a lot, I think, once you get into this sort of what do I need to live better, live longer, live well, it's do something, and a lot more than nothing, and more of something is probably. But the big change comes in the initial. So if you can go from 50, to 60 grams of protein, that's probably going to help. If you can go from 60 to 70, then all of those things, and it's sort of small changes that begin to make bigger differences. So yeah, absolutely, try and hit that daily protein intake, be physically active, keep a high VO2 max, and try and stay strong. And that's not a bad message, right? You like to keep things simple.
So the content around plant versus animal protein was something that was very surprising to me. It was very interesting to hear that we can, in certain circumstances, create proteins that can be helpful for people if they want to remain on a plant-based diet. I will still argue strongly that animal-based protein is far superior because it's more complete and has less of the anti-plant nutrients. But just to give that idea a little bit more space, we wanted to go back to an interview that we did with Dr. Hamilton Rochelle, who specifically did a study on vegan bodybuilders using plant-based and vegan proteins, which I thought was very interesting. And again, as long as it gives us a different perspective, I think it's valid to include here.
You're vegan, all you get is plant-based protein, so you're not gonna gain muscle, you're not gonna bulk up and get muscle strength and muscle mass and all that. And again, there's plausibility to this argument, but they're based on acute studies, more aimed to investigate the physiological aspect of nutrition, and it's not really a clinical trial where you assessing a clinical parameter such as muscle mass. You're assessing like biomolecular pathways and different molecular and physiological responses, and it all pointed towards a better response when you eat animal protein when you compared to the same amount of plant protein. But what we wanted to do is that the literature on this topic was actually more it was scarce in a way that it didn't really investigate it. Those eating exclusively plant-based proteins diets, they're more like, then let's get a bunch of omnivores and we supplement them with either with plant protein or animal protein, and look at these acute responses and see what happened. And again, it seems from these early studies that the animal protein was always eliciting a greater anabolic response than the plant protein. But our study was focused on the long-term response. So what we did is that we got a group of vegans. We wanted to study individuals that would consume exclusively plant-based diet. So you used vegan as a model for that, and we got a matched omnivore individuals, all healthy young individuals in this study. They were similarly active. They were physically active individuals. They were about the same age, same height, same muscle mass, same muscle strength at baseline. And we did this very thorough assessment of their eating habits, so we really understand what their habitual dietary intake was and how it fluctuated over the days, because we wanted to do a more fair comparison. What does that mean? It means that we wanted to investigate if vegans and omnivores, both under adequate protein intakes, would differ in their ability to respond to a strength training program. So by understanding what they ate regularly, we could design or individually tailor supplements to elevate their protein intake, their daily protein intake. And what we wanted to do is have people eating 1.6 grams per kg body mass, which seems to be the breaking point to each protein. Doesn't matter. More protein won't make you gain more muscle mass. So that'll be the adequate amount of protein, generic value. So everyone would have to take 1.6 grams of protein a day. So to the vegans, we offered soy protein isolate. So they still under a 100% plant-based diet. And to the omnivores, we offered whey protein, and they add up to 80% of their protein coming from animal sources. So we're comparing two very different groups in respect of their protein source. All else was pretty much equal. No difference in energy intake. They're training the same. They're training with us. So it's a supervised training program. We individually supervised every training session. We did a whole bunch of assessments of these guys at a baseline and after 3 months of intervention. And we wanted to assess muscle gains in different levels. So we assessed them with DEXA scans. And DEXA, they really don't look at muscle mass. They look at lean mass. And lean mass is not all muscle. There's water, there's connective tissue. Everything that's not bone or fat is called lean mass in that sense. So we're looking at more macro parameter, so lean mass. Then we went on to look at muscle cross-sectional area by ultrasound imaging. So we have a technique where we can capture a cross-sectional image of your thigh muscle by ultrasound technique, and we can calculate what the cross-sectional area of that muscle is. So if you do that assessment pre and post intervention, you know how much you add up in that cross-sectional area, and that accounts for muscle hypertrophy. But we wanted to look at muscle in a more deeper level as well. So we took muscle biopsies of these individuals, both pre and post intervention. And we looked at the muscle fiber cross-sectional area too. So we have 3 different levels of assessment to make sure that we capture any possible differences in their ability to respond to training. And of course, we did some functional assessments as well. So we look at muscle strength gains. And to our surprise, and I wouldn't say surprise, but to some people's surprise, what we found is that the vegans and omnivores, they gain exactly the same amount of muscle, no matter what the technique that we used to assess it was.
Wow.
They gain the same lean mass, they gain the same muscle cross-sectional area, they gain the same fiber cross-sectional area, and they gain the same muscle strength as well. So our conclusion to this study was that given the protein intake is adequate, there shouldn't be any differences in your ability to gain muscle while being vegan. But of course, we have to restrict this to healthy young individuals, and that may not play it out exactly the same when we talk about some specific population, let's say elderly or those with some chronic conditions that might hamper or might compromise the muscle response. Are not saying that it's going to be different, but we didn't test for that, so we cannot extrapolate our findings, because we know that elderly, they have a lesser anabolic response to either nutrition or exercise, or the combination of both, to be fair. So elderly has what we call the anabolic resistant response, which basically is to the same anabolic stimuli. The response of an elderly person is usually less of that seen in a healthy young counterpart. So we don't know how protein source might affect this. Even though we're giving enough protein to an elderly individual, that still might be a point of difference. We don't know. So we like to be conservative and confine our results to what we studied, which was healthy young individuals in that particular study.
So I definitely wanted to include that clip so that it can be really helpful for people who are still trying to follow a plant-based diet and still want to grow muscle. It's just really important to understand the context of that and understand that even so, following plant-based diet, it's still very important to focus on protein. So I'm going to read the conclusion of the study that Hamilton Rochelle was just talking about. A high-protein, exclusively plant-based diet, which is a plant-based whole foods diet with soy protein isolate supplementation, is not different than a protein-matched mixed diet, so that's a mixed whole foods diet with whey protein supplementation, in supporting muscle strength and mass accrual, suggesting that protein source does not affect resistance training-induced adaptations in untrained young men consuming adequate amounts of protein. So I just wanted to read that to really emphasize that even if you are trying to follow a plant-based diet, you need to emphasize protein in the diet. And it's also fair to say that these people were supplementing with plant-based supplements, which is taking more of the isolated form of protein. This is not necessarily going out and eating a bunch of soybeans to be able to get that protein. So even Dr. Hamilton Rochelle admits later on in the interview that leucine is very, very important and one of the most important amino acids to get. And that can only really be found in good quantities in animal foods, not in plant foods. In fact, the plant foods that are cited for having the most leucine, are things like soy, legumes, and greens. And those foods are going to be very, very, very high in anti-nutrients. Plants will fight back, as we'll learn later on in the episode. We're going to go now to Dr. Ben Bikman, who is a world-famous insulin researcher down at BYU. He is the author of Why We Get Sick, and he's going to start out this conversation by talking about insulin, which I think is relevant. We're going to get to the protein and the fat also, but wanted to start out with him talking about insulin, which is really in his wheelhouse, and then we'll slowly transition over to talking about protein.
The solution in the case of insulin resistance is turn it down. Turn down the volume here. Give the body a break. Give the cells a break from the incessant insulin, and all of a sudden, they will become more insulin sensitive.
Are carbohydrates the only thing that increase insulin production?
Yes, in general, yes. So if we look across the three macronutrients, carbohydrate, protein, and fat, carbohydrates are without a doubt the greatest stimulus of insulin. But of course, that it encompasses a tremendous range. And I would want anyone to know that when I'm speaking about the benefits of a low-carb diet, I am in no way attempting to equalize broccoli with a donut. So there's an enormous spectrum of what a carbohydrate will do to insulin. In general, grains and sugars, of course, will have a significant effect, and vegetables and certain fruits will have a modest effect. That's the general theme, at the risk of needing to get into more detail. Protein will have a modest effect. When protein is consumed on its own, like pure whey, it can have a more than modest effect, where it can be pretty quite consequential, likely. And I think what's relevant there, and maybe I'll finish this and just say fat has no effect. There are some people who say, well, fat does, and there is limited evidence to show that. And the studies that show that there is a statistical increase in insulin with fat, it's when the person has consumed about 500 to 600 calories of fat. And then the little insulin curve at about 2 hours is statistically significant, but I would argue it's meaningless, where it goes from like 5 microunits per mil up to 8 microunits per mil. And so that the statistician says, oh, well, that reached a significant level. And I, as a physiologist, would say, yeah, but that's not meaningful. But nevertheless, I'm going to be bold to say there's essentially no effect to insulin on fat or response to fat. And then protein, there can be. But if you eat that protein with fat, the insulin effect is significantly reduced. And I think that's relevant because in nature, God designed, and indeed I'm a very religious person, so I am going to be bold to say it that way. But if that offended someone, they would just say nature. But I'm not pagan, so I'm not going to say Mother Nature. I will say God designed proteins to come with fat. And in nature, they do. All of the best proteins, or literally every protein comes with fat. And the best proteins for humans are undoubtedly the animal-based proteins. And I do mean that very objectively, quantifiably. Animal proteins beat any plant protein in the world. And that is eggs, meat, and dairy. They are the best protein sources for humans. This has been quantified. There should be no debate on that. Those all come with fat. And so my sentiment with regards to protein is eat it with fat. It's how it's supposed to be. Protein is not supposed to come alone. When we eat protein with fat, the combination of those two allows us to digest the fat, to digest the protein better because of the fat. That has been shown. And protein and fat are more anabolic than protein alone. That was a fascinating study that had people working out, and they quantified the degree to which the muscles made new protein, had them, in other words, got bigger with muscle protein. Then they had the people eat a load of protein, the best, which was egg white, and then measured protein muscle growth. And then they had them eat egg white with an egg yolk, which is this, what I consider a divine ratio of 1-to-1 of protein to fat by mass. And the muscles got bigger still than the protein alone. So if you have, when I imagine people listening to this and they're so interested in getting enough protein, which I applaud, I think that is good. We should be prioritizing protein. It's one of what I consider to be the pillars of a smart diet, but you must get it with fat. Don't artificially get protein alone. So I would even say, don't just scoop out a scoop of whey protein. That's not the way you're supposed to get it. If you are going to get whey protein from a supplement, which I think is fine, get it with fat. In fact, at the risk, I am a little reluctant in stating this because I wouldn't want someone to think I'm anything but a scientist, but I am a little more than a scientist. It was my frustration with pure or heavily skewed protein shakes as meal replacement shakes that I, in fact, designed my own. And I will just say this, anyone who wants to learn more, go to gethealth.com, and health is spelled HLTH. And basically this was a meal replacement shake that was built on a pillar of 1-to-1 protein to fat. And so, the best proteins, egg whites and whey, and that matched with some of the best fats, mostly from fruit fats, just because they're more stable. And that was coconut and olive and a little bit of ghee. Nevertheless, awesome. That little infomercial's done. But when people focus on protein and fat, focus on, if you want to prioritize protein, do it. That's great. But let the fat come with it the way God intended. Our bodies are built to take it that way.
I love that. No, that's great. We will be sure to link that in the show notes. I want to go back to something you said. I am about, 30 miles north of you right now, in the valley to the north, both in Utah, practicing distancing. I look outside and I don't see many things growing right now. It's really cold. I'm kind of bundled up. And I look out on the land and I don't see many things growing. I don't see fruit. I don't see vegetables.
Yeah.
I don't see the wonderful tomatoes I had a few months ago. Everything's kind of sleeping. And so I think let's go back 10,000 years and look at this valley and say, where am I going to find my food? And you're right. My only shot at finding food this time of year is going to be hunting animals. And they are going to come with fat and protein, but carbohydrates are going to be exceedingly rare. I may not come across them for many months. Yet in the summertime, I might find a lot of them for a very short period of time. Can you explain how that was beneficial for us as we evolved?
Yeah, no, absolutely. In fact, I like that you're seeing the world that way. I do think there are some perhaps lessons we learn, or we can learn or relearn by wondering how our ancestors might have lived. Not that we're going to attempt to replicate all that. No one would want to. Now, of course, I'm not an anthropologist, so I'm not a scientist of sort of human history and changes over time. But I would say here, certainly in the arid conditions of Utah, but even the same would apply in less arid places like in Texas, where I was down in Houston. That's a lush area, but you just don't find plants spontaneously growing edible foods. The vast, vast majority of all plants in the world are completely inedible. In fact, indeed, if we try to eat them, we become sick. And if we persisted in eating them, we would die. The vast majority of plants are not consumable for humans or even most animals. And the fact that we have as many plants as we do right now is because we've bred them to be edible. We've bred them to exaggerate what we want and to minimize these molecules that we don't want. including molecules that people are getting a lot of when they're getting their plant-based proteins that are physically inhibiting their intestines' ability to digest the very proteins they're eating. Plants, in a way, I don't mean this to sound dramatic, but they fight back by putting chemicals in them to discourage us from wanting to eat them. So around us, if we were hunter-gatherers, we would most certainly find some success. And I believe around here, much of that would be, random berries, and maybe some tuberous, roots that we could eat, and maybe a few more, and just undoubtedly, and I can't speak to them just because I'm not familiar enough with that area of research. So we would be able to get some plants, and many of them would become ripe towards the end of summer and early fall. And so even in the spring, for example, or even in the middle of the summer, although if you have your own garden, in fact, you tell me, I haven't had a garden since I was a boy. Nothing's coming ripe in the summer, right? Or maybe towards the end of summer.
Yeah, that's when you get those great tomatoes.
Yeah, right. So this would be like July, August. Is that right?
Yeah, that's right. I haven't gardened in a few years either, but my friends have, and I still get tomatoes every now and again.
Yeah, good. Well, but that's my point, though, is that there's a significant time where, well, regardless, even then, even in the summer when things would be full bloom, undoubtedly, I am just convinced our ancestors would have still been heavily reliant on animal-based foods. These sources of carbohydrates, which are fine, that's wonderful. I have no problem with them. They would have almost always been a bonus. In other words, hey, look, we got some berries. That's awesome. Let's add them to the meat that we're eating, or whatever. It's dessert after the meat. But humans, it makes me very curious how people could claim that humans are not omnivores. We are, or even more carnivore than we are herbivore. A human cannot live on plants alone.
So Dr. Ben Bikman mentioned that he doesn't consider himself an expert in human anthropology. So we're going to cut away here for a second. Luckily, we have talked to experts in human evolution, and we're going to start with Dr. Mickey Bendor, who is out of Israel. He is a paleoarchaeologist who spends his time studying our human evolution through the Paleolithic era. He really categorizes humans as fat hunters based on his really exciting and interesting research. And then we're also going to hear from Dr. Bill Schindler. He's also an archaeologist, and he is the author of the book Eat Like a Human. We have hosted him twice on our show. We've also hosted Mickey twice on our show. They've both been fabulous. Let's cut away to hear from them and their opinion on human evolution. I want to go back to the design of Homo sapien, especially. And some people would argue that we are omnivores and we can eat animals and plants and both, work and are totally fine. I've heard you describe this in the past. Would you agree with that? Are we omnivores?
Yes, definitely.
Okay.
There's no question about it. It's like, no. The only problem with that, using the term omnivore, is that we, at the same time, attach to it wrongly unlimited flexibility. So this is not the case with omnivores. The omnivores, for instance, there's a paper that took like 139 or 7, if I remember correctly, mammals, again, terrestrial mammals, and checked their diet and found out that 80% of them are omnivores. So in general, mammals tend to be omnivores. We are not unique in that sense. But if you look at the diet, most of them had 70% or more coming from either plant or from animal. So the conclusion of the people who wrote the paper is that mammals are specialized omnivores. Okay, well, you can be omnivore and you can be specialized. So my assertion is that yes, we are omnivore. I can't deny it. We have the capacity to consume plants, but we could not be so flexible because of what I told you at the beginning, the energetic return. If the energetic return is low, you just cannot be so flexible. You have to get your calories. And you see it in the evolution. You see, for instance, that the large intestine, which really is an organ to consume plants, to get energy from plants. Most plants have very high fiber. And the way to extract energy from that fiber is in the large intestines by bacteria, okay? By the way, the product that you get the energy from is, of course, fat, yeah? A special kind of fat, short-chain fatty acids.
Yeah, that's right.
But it's a fat. So most animals, by the way, get a lot of their energy from fat. Whether from fiber, from bacteria, or from eating fat. So in any case, the evolution of humans, if you take a chimpanzee as like a beginning, we have large intestines that are smaller by 77%, according to my calculations.
Wow.
That of a chimpanzee, the same size, if a chimpanzee had the same size as ours. So you see that the evolution is away from plants. Now you have a disadvantage of from getting plants because you cannot utilize all the energy in the plants.
Thank you so very much for listening to this special episode taken from the Boundless Body Radio Premium Podcast. If you haven't already, please follow our show on Apple Podcasts and be sure to leave us a rating and review on that platform, as it is the best way to continue to get our message out to new people all over the world. And as we said in the introduction, feel free to book a 30-minute complimentary session with us on our website at myboundlessbody.com so we can discuss your health and fitness goals and help you come up with a plan. Thank you so very much, as always, for listening to Boundless Body Radio.